Assalamualaikum and good day everyone. Welcome to week 3 of DAT11503 Programming Fundamentals. I am Dr. Hafiza binti Muhammad Hanifah from the Center for Diploma Studies at UTHM. I am excited to guide you through today's topic. Before we begin, ensure you have your notes ready and follow along with the examples I will show. Let us quickly revise what we covered in the first part of topic 2. We will begin with understanding the characteristics of C++. Let us look at the first characteristic. Modular means that C++ allows us to break problems into smaller, manageable modules or functions, which makes the code easier to write, debug, and maintain. Next, C++ is portable as a program written on one OS that can be executed on another with minimal or no changes. It is because C++ is a compiled language that generates machine code specific to an OS but follows standard conventions. C++ also has a rich library as it provides many inbuilt functions that save time in software development. Another characteristic of C++ is a hybrid programming language, meaning it supports both procedural and object-oriented programming. It is also case-sensitive, meaning uppercase and lowercase letters are treated as different. Do you remember that C++ has a total of 96 characters? These include 52 letters covering uppercase and lowercase, 10 digits from 0 to 9, 29 special characters, and 5 white space characters. Each plays an essential role in coding, as I explained in detail during my previous lecture. This slide provides an overview of tokens in C++, which are the fundamental building blocks of a C++ program. Tokens are categorized into 5 main types: keywords, identifiers, constants, operators, and punctuators. Do you still remember what each of these represents? The following are rules in the naming convention in C++, which provides guidelines for defining valid identifiers in a program. Remember that the names must start with a letter and can contain letters and digits. The underscore is a letter and can be used in names. Keywords like int and float cannot be used as names. Both uppercase and lowercase letters are allowed, but they are case sensitive. Special characters like semicolons, periods, spaces, slashes, and commas are prohibited. Following these rules, you can create meaningful and readable names in C++ programming. In C++, data types define the values a variable can store. There are 4 main types: integer, character, floating point, and boolean. Over the past 2 weeks, we have covered topic 1 and part of topic 2. Today, we will continue with the second part of topic 2. Just a reminder that next week, we will have a short quiz covering topics 1 and 2. So, make sure to review the key concepts we have discussed. Today, I will continue with the second part of topic 2 covering the following subsections. Please give your full attention. Variables are storage locations in memory. They store different values of the same type. A variable definition specifies its name and type, which must be defined once before use. Variable initialization assigns a value when defining a variable. An equal sign is used to assign values. The right side value or R value is stored in the left side variable L value. Variable assignment happens when a value is given to a variable after it is defined. Please remember that the variable must exist before assignment and an equal sign is used to assign a value. The syntax is shown on the slide. The slide provides examples of how variables are defined, initialized, and assigned values in a program. Now, let us explore constants. There are 2 types: declared constants and defined constants. Can you differentiate between them based on the examples given in the slide? Declared constant needs for a const keyword, whereas defined constant need for the preprocessor directive. Previously, I mentioned bitwise operators when we discussed operators in C++. In today's lecture, I will explain how bitwise operations work. Let us begin with the AND operator. Consider the following example. We have declared 2 integer variables, a and b, and assigned them the values 12 and 25 respectively. We must first convert the numbers into binary to understand how the bitwise AND operator works. The bitwise AND operator compares corresponding bits of two numbers and returns 1 if both are 1, otherwise it returns 0. Thus, A and B results in 8. The bitwise OR operator compares corresponding bits of two numbers and returns 1 if at least one of the bits is 1. It only returns 0 if both bits are 0. Let us use the exact value of two integer variables in the previous example. Applying the bitwise OR operation results in 29. The bitwise XOR operator compares the corresponding bits of two numbers, returning 1 when the bits differ and 0 when they are the same. Using the same integer values as in the previous slide, the operation yields a result of 21. The bitwise NOT operator is a unary operator that flips all bits of a given number. The slide presents the formula for computing the bitwise NOT in integers. For example, applying this operation to 35 yields negative 36, while for negative 150, the result is 149 as demonstrated on the slide. The bitwise left shift operator in C++ shifts the bits of a number to the left by a specified number of positions. It is equivalent to multiplying the number by 2 raised to the power of the shift value. In the example given on the slide, the number 3 is shifted 2 places to the left. By applying the formula, the result is 12. The bitwise right shift operator in C++ shifts the bits of a number to the right by a specified number of positions. It is equivalent to integer division by powers of 2. In the given example, 9 is shifted 1 place to the right. Applying the formula, since bitwise operations always return an integer result, the decimal part is discarded and the final output is 4 and not 4.5. We will explore how mathematical expressions are evaluated in C++. We will go through 3 different examples step by step. We start with the expression 2 plus 3.5. Here, 2 is an integer and 3.5 is a floating point number. In C++, when an integer is added to a float, the integer is automatically converted to a float before the addition occurs. This results in 5.5. Next, we evaluate 6 divided by 4 plus 3.9. The division 6 over 4 involves 2 integers, so C++ performs integer division discarding the decimal part. This gives us 1. Adding 3.9 to 1 results in 4.9. If you wanted 6 over 4 to produce a decimal result, at least one of the numbers should be a float, such as 6.0 over 4. This would yield 1.5 and the final sum would be 5.4. Finally, we analyze 5.4 times 2 minus 13.6 plus 18 divided by 2. According to the order of operations in C++, multiplication and division are performed first, followed by addition and subtraction. Thus, the final result is 6.2. By understanding these rules, you can accurately predict how C++ evaluates mathematical expressions and avoid common pitfalls in calculations. In C++, typecasting explicitly allows us to change a variable's data type. This is particularly useful when working with arithmetic operations involving different data types. Let us go through an example to understand this better. Consider the following declarations. X is a double and Y is an integer. Now, let us perform typecasting on some operations. What happens here? We first add X, that is 3.7, and Y 25, resulting in 28.7. Then, int converts 28.7 into 28 by truncating the decimal part, so z gets the value 28. In the second case, casting x before addition, x that is 3.7 is first cast to an integer, becoming 3. Then 3 is added to y, that is 25, resulting in 28. Thus, x is updated to 28 even though it was initially a double. That is a wrap for topic 2. We have just covered typecasting, which is the last subtopic. this video helps you understand programming better. I would love to hear your thoughts, so do not forget to comment on this video as part of your attendance. Your feedback helps me improve future lessons. I'm looking forward to seeing all of you in person soon. Take care and have a great day.